Well, good morning. Man, it's 5:17. It's going to be a while to get my coffee ready. Little Dunkin' Donuts love in the morning. Ready for day. I don't even know what day I'm on. It is 5 o'clock in the morning. Oh my gosh, what's going on? Here we go. I got a new computer. Yes, I did. My other one crashed. Finally crashed. So hopefully this one's a lot faster. And, well, it actually is a lot faster. But it cost me a lot of money. So hit the ads. Maybe I can get a penny or two back. Wait, Dunkin' Donuts, you could sponsor me. Dunkin' Donuts K-Cups. All right, so I know I put B here. We're going to talk about combinations of permutations today. B, on my calculator, this is the menu. 5-3. Again, I'm using the TI Inspire, so this is for my students. If you're watching this and you don't have a TI Inspire, you'll have to figure out where the probability, permutations, and combinations information is. So the first thing we're going to talk about is combination. Now, we did a little bit of combinations earlier when we did binomial expansion, when we had a problem like this. 5 minus, 1/2 x to the 5th. And I said, expand that. You had to do, 5C1, 5C0, 5C1, 5C2, 5C3, so on and so forth. Combinations is the number of ways of picking a group when order does not matter. So order does not matter. When order does not matter, we use combinations. And the notation for this is NCR. Now, when you put it on your calculator, you're going to get an NCR and then a parentheses. And when you do that, you'll have to put N, comma, R. I'll find a calculator for you. It'll probably be in the show notes, or I'll try to put a link on it somewhere in this video. Maybe it popped up right now. Who knows? I don't know. But anyway, this N stands for, let's do it in layman's terms, total number to choose from. And if you were in class the other day, I said, yeah, okay, we got like 25 guys in class, 25 people in class, not guys, girls and guys in class. And let's say I want to, and this is the number you want. So I said, listen, guys and girls, I need 4 of you to come over here and help me sort papers. Right? Doesn't take any strength, doesn't take any brain power. If I want strength, I go with the guys, I go brain power, maybe I go with the girls, you know what I'm saying? Sorry, guys. You're sort of, well, whatever. Just kidding. Anyway, that'll get me in some trouble. Don't put any hate in the comments. I don't care about hates. But if I wanted wait a second. I got to pause this for a second. If I can figure out how to pause it. Okay, sorry about that. I had to set up my pens up here. I didn't have my pens set up here because I got a new computer. Anyway, I don't even know where I was at. Combinations. The number one. So I was in class the other day. I'm like, okay, if I want 4 of you, if I got 20 of you and I want to choose, there's 20 of you and I want to choose 4. It doesn't matter how I choose you to help me. Like a first person I pick gets, $10 an hour, and the second person gets $5 an hour, the third person gets $2 an hour, and the fourth person has to pay me. I'm just asking you to help. So it doesn't matter how I help you. When we're talking about those, we're talking about committees or teams or groups. This is how you're going to remember combinations. Combinations will help you out with if you want committees, groups, or teams. Now, permutations. Order makes a huge difference. Order matters. This is like if you have a race and you want to know how many times the 50 people that are in the race can come in first, second, and third place. It makes a huge difference for permutations. The notation for this is NPR Oops. And on your calculator, it'll give you a parentheses, and you got to put n comma r. And again, n stands for the total number of people to pick from. R stands for the number I want. Now, when you're doing this, I had a kid put in 5C20. And I'm like, what? You've got 5 people and you want to choose all 20 of them? That doesn't make much sense. So when you're doing this, you got to remember the large number comes first. That's the number you have to pick from, and the small number comes second. You'll see how this works. All right. So let's say I have drama club, and there are 23 members of the club. And I want to pick 4 of them for a committee. Now, if they're a committee, they're just going to be a group of people that work together. So if that's a committee or group, you're going to use C. I don't have my calculator up. Oh my gosh, I don't even have my calculator on this computer. That's one thing I forgot. Son of a... Pause again. Let's see if I can find out where I can get the computer calculator from. All right. Oh, by the way, there's 48 days, 1 hour, and 30 minutes until your Regents exam. I don't know if that's right. 1 hour and 30 minutes would put us at 7 o'clock. We need this to be 8 o'clock. Oh, it's off by an hour. Anyway, it's 2 hours in. Anyway, if you go to my website, mrkrausmath.com, click on the one for a scientific calculator. For now, this is the one I'm going to use for NCR and NPR. In this particular case, I think I had 23. I'm going to use NCR, so I'll click on NCR, 23, 4, and I get 88.55. Oops. Minimize. Where was I? OneNote. So it's 23, choose 4, and we said that was 88.55. Now over here, this isn't a great, perfectly worded question. I said I have drama club, and I want to know how many different ways are there to pick president, vice president, secretary, and treasurer. But what I should have said is if whoever I pick first, or whoever gets the most votes gets president, whoever I pick second, not votes, but gets the vice president, whoever I pick third gets the secretary, and whoever gets fourth gets the treasurer. So, again, on this problem, we've got 23 members, but we're going to pick 4 of them, and then we're going to pick them using permutations, and so you're going to see that this is a much larger number. 23, that would have been a huge number. 23, 4. And it's 212,520. So 212,520 ways. So just same amount of people, but now when you switch 2 of them, that makes a difference. With committees, it doesn't make any difference, or groups. So take 30 seconds. You can hit the pause button right now while I take a drink of coffee and put a P or a C next to each one of these, and then see if you got them right. Thank you, Dunkin' Donuts K-Cups. I'm back. Picking a team for a gym class, combinations. Team. Ways of choosing vice president, president, secretary. If the order matters, it would be P. If you could just pick a group and then let them decide, well, then it would be C. 5 apples on display, C. 3 ice cream toppings of deliciousness, combinations. The ways and runners coming first, second, third, permutations. Reading books off a shelf, combinations. Choosing a 9-person batting order, believe it or not, makes a huge difference what order they bat in, so that has to be permutations. All right. So, anybody know how to read this? It's read 6! 6! With some lots of emphasis. 6! I was just kidding. It's not. I know I said this. It's kind of a hard way to do it. That's a pain in the neck. If you go down next to the G button on your calculator, so look for the G button. Right next to it, you'll see a question mark and an exclamation mark button. Use that button. That's an easier way to do it. So anyway, factorial. This is read 6 factorial. You probably already learned this. What it stands for is 6 times 5 times 4 times 3 times 2 times 1. Hopefully my scientific calculator works for that. I think I got it here. Clear. 6 factorial. Enter. 720. So yes, it does. All right, perfect. So why do I need that? Well, let's say I gave you an example of like the letters A, B, and C. And I said, okay, how many different ways can I arrange the letters A, B, C? Well, that's one arrangement. I can go A, C, B. That's another arrangement. Okay, there's no other way to start with A, so I'll start with B now. B, A, C. Or B, C, A. There's no other way to start with B, so I'll go to C, C, A, B, and C, B, A. So it turns out there's 6 ways of doing it. Well, originally we had 3 items, and if you do 3 factorial on your calculator, you'll see that that's 6. So 6. Another way of writing this is I want 3 things and I want to pick 3 of them. That's the same as 3 factorial. 3, 3, 3. Oops. 3, 3. 6. Same thing. Now I'm not saying permutations are the same, but if you choose all of them, then it's the same. Probably should have made that reference in class. Oh, that's near my head, isn't it? So what if I said, instead of A, B, B, I use A, B, B? Well, how many different ways can I arrange the letters in A, B, B? Well, if I wrote down A, B, B, and I said, okay, that's different, and you'd say, no, it's not, and I'd say, yeah, it is, and you'd say, no, it's not, and I'd say, yeah, it is, and you'd say, no, it's not. We could do that forever. Till one of us punches the other person in the head, or we settle down and have some Dunkin' Donuts coffee. But I could say, look, I just changed the B's. And you'd say, that doesn't make a difference. That's not anything different. You're right, all right. So the only way to change this is to move the A. So we go B, A, B, and then I would go B, B, A. Those are the only, so in this case, even though I started with 3 letters, because 2 of them were the same, I only get 3 different ways of organizing those letters, or 3 different arrangements of those letters. So that's what we're going to talk about for a couple seconds here with Tallahassee. Hardest part about this is actually counting the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if all those letters were different, then I would have 10 factorial ways of arranging those letters. Now, if I go to my calculator and I do 10 factorial, what you're going to find is this is really close to my salary. 3,628,000, 3,628,800. If they were all different, there would be 3,628,800. It's close. It's a little low, but it's about my salary. But unfortunately, they're not all the same. There's a lot of them that repeat. So what we got to do is we got to get rid of the repeaters. Like you could argue these are 2 different words because, A, I changed the 2 L's. Look, the L's switched. But unless they're colored and you have a black L and a purple L, who's going to know? We don't know. So anyway, we got to get rid of the repeaters. We're going to get rid of the repeaters. So I'm going to come by and grab a different pen because I'm bored with that pen. So I look through and I say, okay, the A is the first thing that repeats, and there's 3 A's. 1, 2, 3 A's. So I'm going to divide by 3 factorial. And then there are 2 L's. So I'm going to multiply by 2 factorial. And then there are 2 E's. 1, 2. 2 factorial. Oh, okay. So now it's going to make a big difference. So we're going to take 10 factorial and we're going to divide by, and I've got to put this in parentheses. This is the hard part about this. 3 factorial times 2 factorial times 2 factorial parentheses, and hit enter. Notice, look what I got up here. That's exactly what I'm looking for. Enter 151,200. 151,200. You know, that's a ton less. That's like 3.5 million less almost. But that's the answer. All right, kids, let's talk about license plates. Because nothing's more exciting than a California license plate, especially when you're drinking Dunkin' Donuts coffee in the morning. How many distinct just means completely different license plates, can California create if the first character must be a 5, the next 3 characters must be letters that don't repeat, and the last 3 characters must be numbers. Now, in the last 3 characters must be numbers, it didn't say anything about repeating. This repeating is a huge issue, right? Notice I got 2 letters here that repeat. That would be a fail. I can't have letters that repeat. So, let's go through it. These represent the 7 letters in this license plate. They're also represent your number of choices. Not the actual choice, it's the number of choices. And there's a huge distinction between that. For example, I was told this first number had to be a 5. If I put a 5 here, that's telling me I have 5 choices for that first spot. I don't have 5 choices for that first spot. I can put a 5 there, but I don't have 5 choices for that spot. I only have 1 choice for that spot. It has to be a 5. Now, for these next 3, they told me they had to be letters. Characters must be letters that don't repeat. Well, there are 26 letters. Hopefully that's not next to my head. I'll put it over here. There are 26 letters in the alphabet. And yeah, 26 letters. So in this first spot, I will put a 26. But since they can't repeat, and I had to put a letter there, that means me 25 letters for this spot. Now I've used up 2 letters. Now I've only got 24 left for this spot. All right. And then the last one said, these must be numbers. So this has to be a digit. You know, someone said, oh, there's infinite number of numbers. Yeah, I know, but you can't put this number as 2 million right here, you know. It can only be a digit. Each one has to be a digit. And they said those can repeat. Well, the digits don't go from 1 to 9. They go from 0 to 9. So that means there are 10 digits. So that means I can put 10 here, 10 here, and 10 here. And the way you do this is you just simply multiply these together. So 1 times 26 times 25 times 24 times 10 times 10. I could put 10 cubed, but probably take me longer to find the cube button. And I get that number. Ooh, they separated up here for us. So that's now 15,600,000. 15,600,000 different ways I can make those license plates. Yes, let's move on. Anybody seen this before? It's in like, isn't that Tom Hanks movie? They had that Cryptic. It's called a Cryptic. You had to do it without breaking the glass there. All right, so let's see what we got here. 5 characters. Notice I've put 5 characters. Remember, these represent my number of choices. The first character must be an even digit. So this first one has to be even. And yes, 0 is even. So that would be a 0, a 2, a 4, a 6, or an 8. So I have 5 choices for that one. The second character must be a digit less than 4. So this has to be less than 4. So that can be 1, 2, 3, or it could be 0. So I actually have 4 choices for that one. And the last 3 characters must be 3 consonants that can't repeat. Well, now a consonant is anything but it's not a vowel. So I take the 26 numbers in the alphabet, I subtract off the 5 vowels. No, Y is not a vowel. and I get 21 consonants. So 21, 20, and 19. Take my calculator out. I multiply 5 times 4 times 21 times 20 times 19, and I get 159,600. So the answer to this one is, I don't want to put it over here, maybe 159,600. All right, let's go through some practice problems. In a hockey, that's what it says. In a hockey, an offensive line consists of a left wing, right wing, and a center. How many lines can the Flyers make with 17 forwards? Well, let's say it matters what order, because it's a left wing, it's specific, it's a right wing, it's specific, and it's a center, so it's specific. So if it's specific about how I pick them, that whoever I pick first is going to go left wing, whoever I pick second is going to go right wing, and whoever I pick third is going to go center, then I have to use P. So this would be 17 pick 3, which is quite a bit more than the other one, so clear 17, 3, 4,080. How many ways can a band choose a drummer, a singer, a guitarist, and a keyboardist from 12 people audition? Again, see, these aren't the greatest questions. I should have picked better questions than these. Let's assume that whoever I pick first has to be the singer, who has to be the drummer, and it has to be. When those are has to be's, it's P. So this would be 12 pick 4, 12 comma 4, 11,880. 11,880. Done. At Wegmans, there's a bin of 40 oranges. How many ways can you choose 2 to purchase? Well, I don't really care how I pick those oranges. There's 40 of them, and I'm going to choose 2 of them because it doesn't matter. I'm just going to have 2 oranges. Like, it doesn't matter if I have like 1 orange and then other orange or just 2 oranges. So that's 40, choose 2. So I'll hit this, 40, comma 2, and I get 780. All right, board with that pen. Going to purple. So how many ways can Chris Harrison choose 10 roses for a bouquet from a bunch of 16? So if you see a bunch of roses in a vase, I know what you're thinking. Should have been an artist. Does it matter that this one's the red one, and this one's the white one, this one's the green one, this one's the pink one, this one's the red one, this one's... It doesn't matter. It makes no difference. It's just a bouquet of roses. So that would be 16, choose 10. So, clear. 16, comma 10. 8,008. Yay! Done with that page. Moving on. This actual word came up on a Regents exam a couple of years ago. So, the word is Tennessee. 1, 2, 3, 4, 5, 6, 7, 8, 9. If they were all different, it would be 9 factorial. They are not all different. We have lots of repeaters. So, 1, 2, 3, 4 E's. So we're going to divide by 4 factorial times 1, 2 N's, 2 factorial, and 2 S's, 1, 2 times 2 factorial. So when you put these on your calculator, just be careful. It's 9 factorial divided by, and all the bottom stuff has to go in parentheses because I can't make fractions nicely on this. But you'll notice what it looks like up here on top. It looks kind of nice. 4 factorial times 2 factorial. By the way, putting in times 2 factorial is kind of annoying because it's just 2. So I could have just used this 2. But the answer is 3,780. All right. Carmen Santiago. Where in the world is Carmen Sandiego? Santiago, whatever her name is. She's encrypted a message. Oh my gosh, Batman. I need coffee. Almost out, and it's cold. Cup doesn't keep it very warm, does it? I need one that keeps it warm. How about a Dunkin' Donuts cup that keeps it warm? That'd be really nice. So Carmen Santiago has intercepted a message where the first character is an English letter and the next 5 are digits that do not repeat. Okay. 1 letter. 1, 2, 3, 4, 5. So in this first spot, I got to put a letter. It doesn't say it could be any letter, but it has to be an English letter. So that's why I say 26 letters. And the numbers that cannot repeat. So 10 times 9 times 8 times 7 times 6. There it is. You bust a move over to the calculator. You go, okay, calculator. 26 times 10 times 9 times 8 times 7 times 6. That's the last one. And hit enter. Did I get that right? 26 times 10 times 9 times 8 times 7 times 6. 786,240. 786,240. Gosh, if only I could make that much money. How many distinct permutations on the word Indiana? 1, 2, 3, 4, 5, 6, 7. 7 factorial. If they were all different. I have 2 I's, 2 factorial. Cross them off so you know you've used them. I have 2 N's, 2 factorial. I have 2 A's. By the way, 2 factorial is just 2, so that bottom is just 8. So I'm just going to divide by 8 because I want to make my life easier. 7 factorial divided by 8 is 630. Wait. Oh, this is 7. Connecticut. Let's do Connecticut. Why do I need such a huge 9? I don't need a huge line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. All right. There are 1, 2, 3 C's. 3 factorial. 2 N's. 2 factorial. 2 T's. 2 factorial. Let's see. 1 O, 1 E, 1 I, 1 U. All right. So we're going to come over here and we're going to clear this out. We're going to go 11 factorial divided by parentheses 3 factorial times 2 factorial times 2 factorial equals 1,663,200. 1,663,200. Every time I write a number like that, I'm like, ooh, if only I won the lottery. I did. I won the coffee lottery. Oh. Thanks, Dunkin' Donuts, for not sponsoring me. 1, 2, 3, 4, 5, 6, 7, 8. Just kidding. 8 factorial. Why do you think I'm awake at 5 o'clock in the morning? You're sponsoring my spaz-holiness. All right, let's see what we got. Only 1 C. We got 1, 2, 3 O's. 3 factorial. 1 L, 1 R, 1 A, 1 D. Oh, that's boring. Clear. 8 factorial divided by 3 factorial. And I could have just divided by 6, by the way. 6720. All right. So how many license plates can New York State create if the first 3 characters, 1, 2, 3, and the last 4 characters, 1, 2, 3, 4. We're going to do them differently. So, tie to that pen. Let's go to orange. First 3 characters are letters. Last 4 characters are digits where repetition is not allowed. Now, it looks as if repetition is not allowed at all. So we're going to go 26, 25, 24. That's for the letters. And over here, we're going to use the digits. And those can't repeat either, so that's 10 times 9 times 8 times 7. So clear out. 26 times 25 times 24 times 10 times 9 times 8 times 7. Enter. 78 million. Holy crap. 78,624,000 ways. I'm going to win the lottery tonight. And I'll still keep creating videos because this is so much fun. As long as I have a Dunkin' Donuts coffee, which, by the way, is empty. Bill Gates can create the first... Wait, how many passwords can Bill Gates create if the first character is odd, first character, the second character is a W, the third character is a letter that's not a W, and the last two are so on? That just helped me get those things out. Okay, let me grab a different pen. So, the first character is odd, so this has to be odd. All right, so there are 10 digits, and this has to be odd, so that means I have 5 choices. 1, 3, 5, 7, 9. The second character is a W, so I only have one choice for that one. It has to be a W. The third character is a letter that is not a W. Well, that everything but not a W would be 25. And the last 2 characters are perfect squares. Ooh, wow. So that looks kind of difficult. But remember, we're still talking about digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those are the only numbers that can go in those spots as far as creating a password. Well, let me highlight the perfect squares. 1, 4, and 9. Now, it didn't say that the perfect squares couldn't repeat, so I'm going to assume that they can. So that means there are 3 choices for here and 3 choices for here. So this could be something like an odd number. 3WA44 or 3WQ94 or something like that, right? But the last one, I have 3 choices for perfect cubes. All right, that's kind of a weird one. So I'll clear that out. 5 times, I'm not going to multiply times 1 because that's boring. 25 times 3 times 3, 1125. So there are 1125 ways. Almost done, kids. Almost done. And hopefully this worked out for, my boy Mark Zuckerberg. How many Facebook passwords can Mark Zuckerberg create if the first character must be an 8, the next 3, so the first character must be an 8. The next 3 characters are consonants. 1, 2, 3. That don't repeat. No repeat. No repeat. Consonants. The last 3 characters are even digits. Even. No repeat. All right, so this one's kind of tricky. You got to be careful here. The first character must be an 8. This has to be an 8, so I only have one choice for it. The next 3 characters are consonants that do not repeat. So that would be 21, 20, and 19. Now this is the last part. I have to have an even number. No repetition is allowed. Well, the even numbers are 0, 2, 4, 6, and 8. You might think, hey, that's 5. But it's not 5 because I already used the 8 over here. So I can't use that again. So that leaves me 4 choices for this spot, 3 choices for this spot, and 2 choices for this spot. So there it is. 20, 21 times 20 times 19 times 4 times 3 times 2. 191,520. Clearly, that would not be enough for Facebook. We need something like 17,423,000 so everybody could have 4 accounts. All right, last one. How many passwords are possible for a cryptic that has a code that has 5 characters? 1, 2, 3, 4, 5. Those can be letters or digits, but no repetition is allowed. So that means it could be either the 26 letters or the 10 digits. That means for every spot, I have how many choices? Hope you're smart enough to figure that one out. I have 35 choices. That's not embarrassing at all. I have 36 choices, 26 letters, 10 digits. But since repetition is not allowed, I only have 35 for this one, 34 for this one, 33 for this one, 32 for this one. Grab my calculator, which I'll just go like this. By the way, let me show you another way to do this. This is 1, 2, 3, 4, 5. I could do 36, comma 5. I believe that'll be the same number. 45,239,040. If you don't believe me, do 36. Oops, clear. 36 times 35 times 34 times 33 times 32. 45,239,000. 45,239,040. All right, that's it. That's all you wrote, kids. If you've enjoyed the Dunkin' Donuts, if you enjoyed my lecture, if you've enjoyed these notes, hit the like button, hit the subscribe button, hit the donate button. I just bought a $1,500 computer. I'm broke. Didn't even come with a monitor. I had to use my old monitor. Using this really old monitor, which is actually not that bad, but it's kind of old. All right, kids. It's been fun and it's been real. And you know it's been real fun. Bye.